Hello viewers, welcome to my channel. I'm Hasham. So far, 4 problems I've completed on solving the LPP by graphical method. In this video, I'm going to explain you about the 5th problem. See, there are 2 methods of solving the problem, linear programming problem. One by graphical method, the other is simplex method. So right now we are learning about how to solve LPP by graphical method. So comparatively this method is easier, but this method have their own limitations due to which we have to apply simplex method. So now in graphical method, first of all we have to formulate the problem as a LPP. First 3 problems we have formulated and then solved. But from 4th problem onwards, the formulated problem will be given in the problem. Simply, we have to find the solution by graphical method, right? So before starting the 5th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep it ready. Take the screenshot, then I'll explain every point in detail. Now, see the problem number 5. Solve graphically. Maximize z is equal to 10x1 plus 15x2. There it is written only 10x. Make it 10x1 and 15x2. Subject to constraints, 2x1 plus x2 is less than or equal to 26. Actually, it is given only less than. Make it less than equal to like this. See, objective function maximize z is equal to 10x1 plus 15x2. Subject to constraint 2x1 plus x2 less than equal to 26. Second one 2x1 plus 4x2 less than equal to 56. And last one x1 minus x2 is greater than equal to minus 5. And last one, non-negativity restriction, x1 and x2 are greater than and equal to 0. This is the problem given. Now we have to solve it by graphical method. First thing is we have to convert the inequalities into equations and then find out the coordinates of every equation. That is the first step. So here, solving by graphical method, converting the inequality into equations and finding the coordinates. First inequality, 2x1 plus x2 less than equal to 26. So I am removing the inequality, I am making it equation. So 2x1 plus x2 is equal to 26. We suppose x1 is equal to 0. Let x1 is equal to 0. Then x2 will become 26. The coordinates will be 0, 26. x1 is 0, x2 is 26. So 0, 26. Second, let x2 is equal to 0. When we take x2 is equal to 0, then 2x1 is equal to 26. x1 is equal to 26 by 2, that is 13. So x1 is equal to 13, x2 is equal to 0. So we got the coordinates of the first equation, right? Then second equation, 2x1 plus 4x2 less than equal to 56. So I am making 2x1 plus 4x2 is equal to 56. Let x1 is equal to 0. So 4x2 is equal to 56. x2 56 by 4, 14. So when x1 is 0, x2 is 14. Now I am taking x2 is equal to 0. So when x2 is equal to 0, so it will become 2x1 is equal to 56. And x1 is 56 by 2, 28. So x1 28, x2 0. We got the coordinates of second equation. Now third inequality is this one. x1 minus x2 greater than equal to minus 5. But the constraint here is minus 5. To convert this minus 5 into plus 5, we can multiply the whole equation by minus sign. So wherever there is plus, it will become minus. Wherever there is minus, it will become plus. The sign greater than will be converted into less than. If we multiply the complete equation by complete inequality by minus sign. So multiplying the inequality with minus sign to make the constraint positive. Here constraint is negative. To make it positive, we are multiplying the whole inequality by minus sign. So what it will become? This plus x1 will become minus x1. This minus x2 will become plus x2. Then greater than equal to sign will become less than equal to. And this negative minus 5 will become plus 5. In this way, we have converted the negative constraint into positive constraint. Now the equation minus x1 plus x2 is equal to 5. Now let x1 is equal to 0. When x1 is equal to 0, then x2 is equal to 5. Then coordinates are 0, 5. Now let x2 is equal to 0. When we take x2 is equal to 0, minus x1 is equal to 5. So if we multiply this equation with minus sign, minus will become plus, plus will become minus. So minus into minus will become plus x1. Plus into minus will become minus. So x1 is minus 5. So x1 minus 5, x2 0. We have calculated all the coordinates of the equation. Now we need the scale. For taking the scale, see what is the highest value of x1 and x2. Here x1 value is 0, 13, 0, 28, then 0, then minus 5. The highest value is 28 for x1. So on x-axis we take x1, on y-axis we take x2. The highest value for x1 is 28. So we cannot take 1 centimeter, 1 unit. In that case, we need 28 centimeter. 28 centimeter is very lengthy space. We cannot accommodate on the paper. So we make it half. Half of 28 is 14. So we take 1 centimeter is equal to 2 units. In this way, 14 centimeter we require for 28 units. So 1 centimeter, 2 units. Similarly, what is the highest value of x2? 26. 0, 14, 0, then 5, 0, 5, 0. What is the highest value? 26. Again we take 1 centimeter is equal to 2 units on y-axis also. Right? Now draw the graph. On x-axis x1, on y-axis x2. Right? We take 2, 4, 6, 8, 1 centimeter is equal to 2 units. So 14 centimeter we can take 28. Similarly, y-axis 1 centimeter 2 units, 2, 4, 6, 8 like that up to 28. Now, the x value is also minus 5. So, I am extending the x1. x1 value left side. So, this 0, minus 2, minus 4, minus 6. Because we are having minus 5. So, we don't require after minus 6. Up to minus 6 we have taken. So, we have taken the axis. Now we have to draw the coordinates. The first coordinate, when x1 is 0, x2 is 26. So here x1 0, x2 26. At 26 you have to put a mark. So here at 26 I have taken a mark. Now x1 is 13, x2 is 0. So x1 13, here 12 and 14. In between 12 and 14, 13 is there. Now 2 marks are there. 26, 13. This is 26, this is 13. Join the 2 points with the help of a scale, straight line, and extend the line. Now we have to see whether it is less than equal to or greater than equal to. If it is less than equal to, then the line should be towards the origin. That's why this arrow mark towards the origin. Origin is this one. Here also less than equal to origin. If it is greater than equal to, we would have written right side. Less than equal to left side. So first inequality. To distinguish, I have written here 1. That means first constraint. This is the line of the first constraint. Now second constraint. Second constraint is x1 is 0, x2 is 14. This is x1 0, x2 14. At 14 I have put a mark here. Right? Then x1 is 28, x2 is 0. This is x2 0, x1 is 28. This is 28. Now join these 2 points 14, 28 with the help of a straight line and extend the line. This is the second line, so write down number 2 here. Second point. Here also second point. Downward arrow, because it is less than equal to type. So downward arrow less than equal to type. Right? Now third inequality. In third inequality, x1 0, x2 5. This is x1 0, x2 5. At 5, I have put a mark here. Right? Then x1 is minus 5, x2 is 0. This is x2 0, yeah, x1 minus 5. So left hand side I have put a mark. Now join these two lines, this positive plus sign, plus 5 and minus 5, and extend this line. After joining these 2 points, extend the line. Then this is the third line, third inequality. This is the third inequality, right? And it is less than equal to type. Towards the origin. Towards the origin means this is the origin. Towards the origin, downward arrow. Now we have plotted all the points. We have drawn the lines. Now we have to find out the feasible region. This line says the feasible region is downward. This line. So our feasible region is not in this area, not in this area. This line says the feasible region is downward. So this is not the feasible region. Right? Now ultimately this line says the feasible region is downward. So this is also not the feasible region. The finally feasible region is this one. This is the feasible region. Now here, the corner points touching the feasible region are O, P, Q, R, S. These 4 points are touching the feasible region. 5 points, O, P, Q, R, S. The shaded area in the above graph is the feasible region, and the corner points touching the feasible region are O, P, Q, R, S. The solution lies at one of the corner point. The coordinates of the corner points are O, P, Q, R, S. Out of 5 corner points, 3 corner points are readily available. Only for 2 corner points we have to solve the equation and find out the coordinates. First of all, O. O is the origin. At origin, x1 0, x2 0. Always. Now P. You can see here P, x1 is 0 and x2 is 5. Here P is the point 5. So by inspection we are getting 5 is the P. So 0, 5. 0 is x1 and 5 is x2. Now Q and R. These 2 coordinates we have to find out by solving the equation. S. S by inspection we can find out. On x-axis you can see S is at 13. So x1 is equal to 13. x2 is equal to 0. So 13, 0. So out of 5, 3 we got it. 2 we have to find out. Now here, the coordinates of Q and R can be obtained by solving the 2 lines intersecting at the point. At this Q, 2 lines are intersecting. At R, again 2 lines are intersecting. So solve those 2 lines and get the coordinates of Q and R. First of all, I am finding out coordinates of Q, right? Now identify which are the 2 lines intersecting at Q. See here, at Q, one line is intersecting 3, the other line is intersecting 2. In a second equation and third equation are intersecting at Q. So the 2 lines intersecting at Q are second equation and third equation. What is the second equation? 2x1 plus 4x2 is equal to 56. Third equation, minus x1 plus x2 is equal to 5. Now we have to solve these 2 equations. First equation, x1, coefficient of x1 is 2. But here second equation, the coefficient of x1 is 1. Both the coefficient must be same, then only we can cancel. So what we'll do? We'll multiply the second equation by 2. Multiply the second equation by 2. Here multiplying equation 2 by 2. This second equation, this one, by 2. So first equation as it is, 2x1 plus 4x2 is equal to 56. Second equation multiply. 2 into x1 is minus 2x1. Then 2 into x2, 2x2. 2 into 5 is 10. Now without changing sign, directly this 2x1 minus 2x1 will get cancelled. No need to change the sign. Automatically plus 2x1 minus 2x1 get cancelled. Now 4x2 plus 2x2, 6x2. 56 plus 10, 66. So x2 is equal to 66 by 6 is 11. We got the value of x2. Now substituting the value of x2 in equation 1. This is the first equation, 2x1 plus 4x2 is equal to 56. In this equation we substitute the value of x2. So in place of x2 I am writing 11. So 2x1 plus 44 is equal to 56. Now take this 44 to RHS, it will become minus 44. So 2x1 is equal to 12, x1 is equal to 12 by 2, 6. So we got the value of x1, 6. So coordinates of Q are 6, 11. x1 is 6, x2 is 11. That's all. So we got here the value of Q is 6, 11. 6, 11. Now we need the coordinates of R. Now see which are the two lines intersecting. The two lines intersecting at R are first and second. Carefully you see R. This is the first line, this is the second line, and this is the first line. The first equation and second equation are intersecting at R. The two lines intersecting at R are first and second equation. The first equation 2x1 plus x2 is equal to 26. Second equation 2x1 plus 4x2 is equal to 56. Now change the sign, minus, minus, minus. Plus 2x1 minus 2x1 will get cancelled. Plus x2 minus 4x2, you will get minus 3x2. 26 minus 56, you will get minus 30. So minus minus will get cancelled. 3x2 is equal to 30. So x2 is equal to 30 by 3, 10. We got x2 value 30, 10. Now substituting the value of x2 in equation 1. Equation 1 is 2x1 plus x2 is equal to 26. So 2x1 plus x2 value 10. So 10 is equal to 26. Take the 10 to RHS minus 10. So 2x1 16, x1 is equal to 8. We got the coordinates of R also. The coordinates of R are 8, 10. x1 is 8, x2 is 10. Come on, we got R. 8, 10. That's all. Now we have all the coordinates of the corner points. Our solution lies at one of the corner point. Which corner point? Now we have to evaluate the objective function. There is no space there. That's why I have written here. Evaluation of objective function. So here, corner points O, P, Q, R, S. And all the coordinates of corner points here, same thing I have taken. Objective function 10x1 plus 15x2 given in the problem in the beginning itself. 10x1 plus 15x2 and z value. Now substitute. In first equation, in place of x1 0, x2 0. So 10 into 0 is 0 plus 15 into 0 is 0. So first z value 0. Second, x1 is 0 and x2 is 5. So 10 into 0 is 0, 15 into 5 is 75. Now x1 is 6, x2 is 11. So 10 into 6 plus 15 into 11, you will get 225. Similarly, x1 is 8, x2 is 10. So 10 into 8 plus 15 into 10, you will get 230. Then x1 13, x2 0. In place of x1 13, x2 0. So you will get 130. Now find out which is the highest value of z. The highest value of z is 230 at the corner point R, where x1 is equal to 8 and x2 is equal to 10. So finally we got the solution. In order to maximize the value of z, x1 should be 8 and x2 should be 10. And the maximum z is 230. That's it. So this is the end of problem number 5. So my suggestion to the students, this OR subject requires a lot of practice. Only listening the lecture and watching the video is not sufficient. Always I suggest to my students to keep a notebook, calculator, pen ready while I'm delivering the lecture. Always note it down, because otherwise you'll forget it. Then only you can be able to get a good command on the subject. The concept will be completely clear and confidently you can write in examination. So follow my instructions, then only you can gain a lot of knowledge from this channel. So if you are satisfied, give a like to the video, share my channel among your group, among your friends, so that more students can watch the video and enhance the knowledge. And my membership option is also open. So students can select that membership option and become the member of my channel. And inshallah we'll continue the next topic in the next video.